Welcome to RGES Pre-Algebra. This is Lesson 22A, Part 2. This just has to do with a review of solving equations that I promised I would give for you a quick review so that you would be ready for your quiz. Now remember, when we're solving equations, we are always what we would say undoing the operation, meaning whatever's on the same side of the equation as the variable I'm trying to solve for, usually x, I want to take everything else away from that side, and we do that by doing the opposite operation. We are actually doing the opposite operation on both sides, but I rarely write it on the side I'm taking it away from, because I just like it a little less cluttery, so it's easier to see the essential part of what you're thinking. All right, so what do I mean by all this? First off, there's 5 basic operations, and we went through this in class, and you just want to make sure that you recognize these. There's 4 operations, and then there's the fraction. So if I have x plus 2 equals 7, x minus 2 equals 7, x times 2, or 2x, equals 18, and x over 2 equals 18. These are 4 operations. When I want to solve for x, I want this to go away, so that I just end up with x equals. So I'm asking, what's the opposite of adding 2, and that would be subtracting 2. So 7 minus 2 is 5. Here, I want this to go away so that I end up with x equals. The opposite of subtracting 2 is adding 2, and 7 plus 2 is 9. Here, I want this to go away, so I end up with x equal. Right now, it's being multiplied. That's 2 times x on the left side. So I want to divide by 2, and 18 divided by 2 is 9. And finally, right now, I'm dividing by 2. I want that to go away so that I end up with x equals, and the opposite of to divide is to multiply. 18 times 2 is 36. The next example would be if I had a fraction with both the numerator and the denominator. Let's say I have 2/3 x equals 15. Why don't we do it that way? Okay. To eliminate the 2/3 so that I end up only with x equals, I'm going to multiply the other side, really both sides, okay, to keep it balanced, but I'm not writing it on the left, and that's just how I eliminate it, and it's going to be the reciprocal. The reciprocal is putting the numerator in the denominator and the denominator in the numerator. So when I'm multiplying by the reciprocal on the right side, I'm going to multiply by 3 over 2. In this case, I cannot cancel, so I would multiply straight across. 15 times 3 is 45 halves, and that's a perfectly good answer. I'm happy with that. What if instead I had 3 halves x equals 15? I want to get rid of this, so I'll multiply the other side by 2 over 3, cancel if you can, and x equals 5 times 2, or 10. Okay. Now there is one other thing that occurs to me that might be a little bit confusing for you, and that is if I had something like this. -7 plus x, I've got a couple more ideas, equals 4. I want to get rid of this, so I just have a positive x equals. So the opposite of -7 is positive 7. 4 plus 7 is 11. So make sure that that makes sense to you. If I had let's say I had negative 7 minus x equals 4. First, I want to get rid of this, so I'm going to add 7. 4 plus 7 is 11, but that's what negative x equals, and I want what positive x equals. So how would I get rid of the negative sign? Well, that's the same as multiplying by negative 1, okay? And if I multiplied, well, you could either say, okay, then divide by negative 1. That's one way to look at it. Divide by negative 1. The other way to look at it is multiply it by the same thing with the, well, in this case, multiply it by a negative 1, because a negative 1 times a negative 1 is a positive 1. Either way, okay. So I'm going to have to, if I had negative x here, I'm going to have to do something to make it positive. Another way I could look at it, I'm giving you 3 ways to look at it, is the third way is I could just say change the sign. Change the sign on the left from negative to positive, change the sign on the right. Make it the opposite sign. So if it's 11, positive 11 here, it would be negative 11 here. So those are 3 ways to look at that concept. Okay? Trying to think what else might stumble you. Now, the 3 rules, the order of how I'm going to solve an equation. First, I will simplify everything on the left and the right of the equal sign before I move anything across the equal sign. Second, when I am solving, if I have more than one thing to solve, I will always eliminate from the side with the variable, okay? So I will always move an addition or subtraction before. So I use a lot of vocabulary. I sometimes say eliminate. Sometimes I'll say move it. Or sometimes I'll say, what else would I say? Do the opposite, okay? So move the plus or the minus before the multiplication or division. What do I mean by that? So if I have 3x plus 2 equals 9. I have 2 things I need to get rid of. This and this. I must move this one first. Move the addition or subtraction before the multiplication or division. So how would that look? The opposite of adding 2 is subtracting 2. So my next step should be 3x equals 9 minus 2. Then I want to get rid of that. The opposite of multiply is divide. So I have x equals 7/3. Let's look at another kind of problem. What if I had this? Whoops, that's not what I wanted to do, sorry. Let's say x over 3 minus 7 equals 4. I'm just making these up, okay? I want to get x equals on the left-hand side. I have 2 things I need to get rid of, my minus 7 and my divided by 3. I must do this one first. You do an addition or subtraction before you do a multiplication or division. So keep this down just as it was above. The opposite of subtracting 7 is adding 7. 7 plus 4 is 11. Now I've got to get rid of this. The opposite of divide is multiply, so I end up with x equals 11 times 3, or 33. If you end up with something where you have, this would be maybe my third step, variables to the left, numbers or constants to the right. What do I mean by that? What if I had a problem like 3x minus 7 equals 5x plus 2? Well, I can't simplify the left. I don't have any like terms. I cannot simplify the right. I don't have any like terms. So now I'm going to move variables to the left. So I need to get rid of this whole thing, not just the number part, the whole thing. I want to move that to the left side so I can combine it with the other x term. So right now, you want to look at this sign right there, whatever sign's before. A no sign is the same as a plus sign. So I want to subtract 5x. Okay. So 3x minus 5x, 3x minus 5x is what I'm thinking, is negative 2x. I want to move the numbers to the right. The opposite of a negative 7 is a positive 7, so I'm thinking 2 plus 7. See how this is working? Sorry, let me get that sign better. 2 plus 7, that's what I'm thinking. And so I get equals 9 on the right. So I've moved, let's do it again. I've moved this to the left with the opposite sign so I can combine it, 3x minus 5x, and I've moved this to the right with the opposite sign so I can combine it, 2 plus 7, okay? Now, I need to get rid of this, and maybe sometimes the best way to think about that, if there's a number there, is right now I'm multiplying, so I'm going to divide by negative 2 with the same sign. Divide by negative 2. Okay. Your answer is going to be x equals negative 9/2. Just moving that negative sign so it's in the numerator or up in front. We don't want it in the denominator. Let me give you another problem like that. Let's see. 5x, plus 3 equals 4, I don't want to do that one, equals negative 8x plus 12. Let's do something like that. I need to move this to this side by adding. So I'm thinking 5x plus 8x, opposite sign. So that would be 13x. I move this to this side. Opposite sign is minus 3. I'm combining these, not multiplying, but like adding them. 12 minus 3 or negative 3 plus 12, either way, right? They mean the same thing. 12 minus 3 is 9. And now I want to get rid of that by dividing 9/13. Okay, so that's what your quiz will be on. Go ahead and review in your book and practice more problems if this does not look comfortable to you. And come to class prepared to cover this on a quiz.